Hi, let's continue. In this video, we are going to focus in the energy cycle method and also dissolution process. So we are going to discuss tutorial question number 10, which the question asks us to use energy cycle method to solve the problem. The standard enthalpy of combustion for carbon, hydrogen, and benzene as given below. So again, you will see that the question only gives us the value without the thermochemical equation. So if you can understand the definition of the enthalpy of combustion, then there will be no problem for you to calculate the enthalpy change for the reaction. So no matter the question is asked us to solve the question based on the energy cycle method or even the algebraic method, step number 1, we need to write out the thermochemical equation. So if the question does not give us the thermochemical equation, again we need to write the thermochemical equation ourselves. So if we want to make sure our thermochemical equation is correct, then we need to understand the definition. So basically, if we look at here, the question is focused on the enthalpy of combustion. So as we know, enthalpy of combustion is heat change when heat release when 1 mole of substance burn in excess oxygen. Okay, so now we have carbon. So carbon burn in excess oxygen gas will produce carbon dioxide gas. So this is the first enthalpy. This is the first thermochemical equation. So second is the combustion of hydrogen gas. So hydrogen gas burn in excess oxygen will produce H2O gas. So if we want to balance the equation, then we have to make sure this is 1/2 mole of oxygen gas. The enthalpy of combustion is negative 290 kilojoule per mole. Last one is the combustion of the liquid benzene. C6H6 liquid plus oxygen gas. So we'll produce carbon dioxide and H2O. Carbon dioxide gas and then H2O gas as well. Then the enthalpy of combustion is negative 3270. However, the equation haven't balanced yet, so we need to balance the equation. 6 mole of carbon dioxide and then 3 mole of H2O. So 3 times 1, 3 oxygen from the H2O, and then 6 times 2, 12 oxygen from the carbon dioxide. So total is 15/2. So these are the thermochemical equations that we write out ourselves based on the understanding of the definition. Okay, after write the thermochemical equation, as usual, we are going to label first thermochemical equation, second and also third thermochemical equation. So because we are going to use the energy cycle method, basically we can rewrite again this equation here so that we can construct the energy cycle. So 6 mole of carbon react with 3 mole of hydrogen gas will going to produce 1 mole of liquid benzene. Okay, so basically this chemical equation, this chemical reaction is showing enthalpy of formation of benzene liquid. Okay, so we start from the first one. We can see the carbon is in the first thermochemical equation. However, in here they are showing us 6 mole of carbon, but here only 1 mole. So means that the first thermochemical equation we need to times 6. Okay, so when you times 6, so it will react with the carbon dioxide gas. So also will be have 6 mole of carbon dioxide. So this negative 390 will be multiplied with 6. So we already applied for the first thermochemical equation. Then the next one, we will notice that from here we have 3 mole of hydrogen gas. So hydrogen gas is at the reactant side. This hydrogen gas also at the reactant side. Means that we can maintain the delta H, the sign of the delta H. However, here show 1 mole, but here is 3 mole. So means that we're going to multiply with the 3. Negative 290 multiplied by 3. And then we'll produce 3 mole of H2O gas. So and then from here, both this carbon dioxide and 3 mole of H2O react. We can see that carbon dioxide gas as the product. So this one also carbon dioxide gas as the product. 3 mole of water H2O gas, steam H2O gas as the product. Okay, so then but now our destination is over here. Okay, so means that we have to from this one goes to another side. So because of we reverse the equation. Okay, here this one is the reactant. Now this is the reactant, and here this is the product. Okay, and then for the liquid benzene at this condition it is product, and then at here this is the reactant. So what going to do is we going to reverse the equation. So if reverse the equation, the change of the sign will be happen. So be plus 3270. So and then don't forget here we have 15 over 2 mole of oxygen gas. Okay, here we need to use 6 mole of oxygen gas, and here we need to use 3 mole of oxygen gas. 3 over 2 mole of oxygen gas. So this number of mole of oxygen gas, 6 mole, 6 times 2, 12, 12 plus 3, so 15 over 2. So with this one can be cancelled out. So then next one we can see that there is the relationship over here. This is the rho delta H1, and then this is the rho delta H2, delta H3, and delta H4. So from here we notice that there is one step from carbon, the reaction of carbon and hydrogen can produce liquid benzene, or we have another method which is going to use then we label here is enthalpy of number 2, which is here delta H2, okay, delta H3, and then delta H4. Then only we will reach the C6H6. So end up we can have this method of writing delta H1 equal to delta H2 plus delta H3 plus delta H4. So delta H1 here is the unknown. So delta H2 is negative 396 multiplied with 6. So we will get the answer which is negative 2340. And then enthalpy of delta 3, 290 times 3, we will get negative 870. and then delta H4 is positive. Over here, positive 3270. Press the calculator, so we will notice that the answer is positive 60 kilojoule per mole. Let's continue with the last learning objective in the subtopic of Hess's law, which involve the dissolution process. So we directly look at the question number 12 in tutorial, how the question going to ask. So from the tutorial question number 9, number 10, 11, and 12, you will notice that basically the question will not give us the thermochemical equation. They only will let us know the value or the magnitude of the enthalpy, but let us know what is the type of enthalpy. For example, this one is enthalpy of hydration, and then also enthalpy of solution. So if you have no idea about the definition of the type of enthalpy, then you are not able to write the thermochemical equation. Once you are not able to write the thermochemical equation, then you are not able to continue to answer the question. So again, just would like to remind you, it is very important to understand all the definition of the type of enthalpy so that you are able to write the thermochemical equation. So look at the first one, enthalpy of hydration is heat released when 1 mole of gaseous ion hydrated in water. Okay, so I repeat again, is gaseous ion hydrated in water. So basically we know that if gaseous ion for the Na plus will be gases formed in Na plus, and then hydrated in water, the physical state will change from gas to the aqueous. And then this one, the reaction, the enthalpy change is negative 406. Next one is the Cl negative. Gases also hydrated in water will produce Cl negative aqueous, and then the enthalpy is negative 368. Okay, next one is the enthalpy of solution is when 1 mole of substance, okay, 1 mole substance dissolve in water. So NaCl is an ionic compound. So that's why the physical state for the NaCl will be solid. So when dissolved in the water, the ionic compound will dissociate to produce Na plus ion and also Cl negative ion. Because they are dissolved in water, so the physical state will be aqueous, which delta enthalpy change is positive 4. Okay, as usual, after we write the thermochemical equation for each of the type of enthalpy given in the question, then we will label the equation 1, 2, 3. Okay. So now we look at this question A, construct an energy cycle diagram. So in this question, it is very specific. They want us to construct the energy cycle and then want to represent dissolution of NaCl. So to start with this, then to start this question, we have to write the thermochemical equation for this solution of NaCl. So basically, we know that the solution of NaCl is similar with the solution of NaCl. So we already write the equation number, thermochemical equation number 3 here. So we just start from here, NaCl solid, and then produce Na plus aqueous and Cl negative aqueous. So the enthalpy change for this question, this thermochemical chemical equation or this chemical reaction is positive 4. Okay, so the next one, beside from the dissolution, so next one we also have the hydration, thermochemical equation of hydration. So as we know, if we want to draw this Na plus gas to aqueous, so now the aqueous is the product. So based on now here, aqueous is over here. So means that at the bottom here, we can write down Na plus gas. So the arrow from the gas to the aqueous, the enthalpy given is delta H equal to negative 406. Okay, so we already settled for the first one as well. Then now we go to the second one, enthalpy of hydration of chloride ion. So again, it is gases to aqueous. So I will write the Cl negative gases at the bottom here, and then the arrow showing from gas to Cl negative. So which is exactly similar with the equation number 2. So the change of enthalpy is negative 368. So basically, we seems like already complete for this question, this energy cycle. But when you look at over here, you will notice that this is the empty. Means that we didn't have a similar starting point. So what we're going to do, we can write one arrow in between Na plus gases to NaCl here. Okay, so we can draw this one here is the arrow you want to point it to the NaCl solid is okay, or you want to reverse the reaction also okay. So basically, we already done for the part of energy cycle to represent the dissolution of the NaCl. So next part of the question, they ask us to calculate the lattice energy. So as we know, lattice energy, there is two parts. One is formation, another one is dissociation. So if the question doesn't specify what is the type of the lattice energy, normally we will treat it as lattice formation. So that is why also the just now when we draw the arrow is pointed to the NaCl solid, because we know that the lattice and the definition for the lattice energy is when 1 mole of solid ionic compound formed from its gaseous ion. So therefore, the product is the solid ionic compound. Okay, and the gaseous ion are the reactants. Okay, so then from this diagram now, we will notice that the departure or the starting point is over here. Okay, so let's remark first. Here is starting point. Okay, so we have to react both lah. And then end up, we will notice that the destination is over here. This is the destination. So let's remark to look. This is the destination. Okay, so we will continue the calculation in the next slide. Okay, after bring the energy cycle down here, so now our purpose is we want to calculate the lattice energy. So if the question didn't mention about lattice formation or lattice dissociation, basically it is referred to lattice formation. Okay, so and then just now we say the starting point is from the gaseous ion, and then the ending destination is the aqueous ion. So from here we know that this, for example, this is enthalpy 1, and then go through to the enthalpy number 2, it will equal to this enthalpy 3 and enthalpy 4. So end up we will write down enthalpy 1 plus enthalpy 2 equal to enthalpy 3 plus enthalpy 4. So enthalpy 1 basically actually is referred to lattice energy. So we just write down here lattice energy. Delta enthalpy change of 2 is 4, and then equal to negative 406 plus negative 368. So press the calculator, then you will get the answer, which the unit supposedly in kilojoule per mole, because 1 mole of solid ionic compound is produced. Okay, let's do a very simple summary. So for the subtopic of Hess's law, basically first, normally when we do the question, we try to the question basically is ask us to calculate the enthalpy change. Okay, so first we can use the formula to solve the question if all the enthalpy of formation are given. Okay, so if measure must be all the enthalpy given are formation. As long as there is one enthalpy given is not formation, then basically we are not able to use the formula. So we are going to use either is algebraic method, or we going to use energy cycle method. So basically, no matter what is the question given, basically it can solve using either algebraic or energy cycle, except the question is very specific, mentioned that we need to construct the energy cycle. So that means that you must be use energy cycle method. If in the question they didn't let us know what is the method that you want to use, you can use any method, is okay. So personally, you'll notice that maybe most of the students will think that algebraic method is easier compared to the energy cycle. But there is, for sure, there is also some of the students think that energy cycle is easier if compared to algebraic method. So will be depends on your interest. Okay. So and then no matter what is the method, and then last part we study about the dissolution process. Okay, so as we know, the dissolution process normally they will involve the enthalpy of solution, enthalpy of hydration, and also lattice energy. So if you notice from the tutorial question number 9, 10, 11, and 12 that we discussed, basically before we start the calculation, we need to write the thermochemical equation. So if you want to make sure that your thermochemical equation is correct, that means that you need to know the definition. Okay, so basically if previously in the calorimetry, we need to focus to the enthalpy of combustion or enthalpy of neutralization. So in this Hess's law, you will notice that if it is involved formula, for sure is enthalpy of formation. Algebra and energy cycle, so far just based on these 4 questions, we notice that it will involve enthalpy of combustion and enthalpy of formation. Basically these two types of enthalpy are quite common. And then in the dissolution, we need to know solution, hydration, lattice energy. So you will notice that basically all the type of enthalpy in the video 8 are going to be used in different subtopic. So generally it's all the definition you must know, and then maybe from here you also can know, okay, certain enthalpy always famous in the certain subtopic. So that's why maybe later end up overall, after we finish discuss the chapter thermochemistry, when you read the question, you have the idea that which type of enthalpy will be involved in this subtopic, and then you will going to write the thermochemical equation. Okay, so I think that's all for the Hess law. So for this thermochemistry, we still have one more subtopic, which is known as Born-Haber cycle.